This is Algebra Lesson 1.2, Evaluating Expressions. So first, a variable is generally a letter that takes place of a number. And then a constant would be a number that's always constant. It's always the same number, whereas a variable is a number that changes. So we're using letters to represent that that number could be a different number every single time. And then an expression would be a combination of the variables and constants. So here I'm going to just say like a variable would be x, a constant would be 3, so x plus 3 would be an expression. Oh look, x plus 3. Write the algebraic expression in words. So we could just say x plus 3. That's how we kind of read it. But I want to talk about other ways to say plus or add. And generally when we're looking at addition, we would also say sum or total. Those are different ways that you could say that. The next one is m minus 7. So we could just write m minus 7. We could also say subtract. And when we're talking about the result of subtraction, we call that a difference. So 3 different ways to say that. Letter C says 2y. Now when there's no operation there, that means multiplication. So we would read this 2 times y or 2 multiplied by y. And the way that we describe the result of multiplication is a product. The next one is k divided by 5. And this one, we would just say quotient. Doesn't really have a third one, but you could say like split into 5 groups. That's another way to think of division. So my next example says translate from words into an algebraic expression. Eve reads 25 pages per hour. How many pages does she read in h hours? So the goal is to write an expression combining the constant of 25 with the variable of h. And the tricky part is trying to decide what operation to use. Should we add, should we subtract, should we multiply, should we divide? So in this case, if she reads 25 pages per hour, how many does she read in h hours? I would do 25 times h. When we try 25h, we don't need the times symbol in there because it is implied when the number and the letter are next to each other. If it's kind of hard to figure out which operation you should use, I think about instead of saying the letter, put in a number there. So if she reads 25 pages per hour, how many did she read in 3 hours? It would be 25 and 25 and 25, which is really the same as 25 times 3. So I would do 25 times h to do that. The next one says, Sam is 2 years younger than Sue, who is y years old. How old is Sam? So younger than, to me, cues subtraction. So if Sue is y years old, younger than, we would do subtract 2. And our third one, Will runs a mile in 12 minutes. How many miles does he run in m minutes? To me, it's like, is it division? Is it multiplication? Let's try subbing in a number to see what makes sense. So let's say 60 minutes. If he runs in a mile in 12 minutes, how many miles does he run in 60 minutes? It would be 12 for the first, 12 for the second, 12 for the third. But basically, I would be taking how many minutes he's running and dividing it by 12 to see how many times I can fit 12 into m. Letter C says evaluated expression for m equals 3, n equals 2, and p equals 9. So we're going to substitute the value for 3 into m and the value for 2 into n, but remember there's an implied multiplication when we have 2 variables or a variable next to a number. So we would multiply 3 times 2 is 6. P minus n, we're going to substitute 9 in for p, 2 in for n, and we have a subtraction there, so 9 minus 2 is 7. The last one we have P equals 9, M equals 3, and if we divide those, we get 3. And our last example says, recycling 14 plastic bottles produces about 1 square foot of carpet. Write an expression for the number of bottles needed to make C square feet of carpet. So if 14 produces 1, and I'm trying to make C, I would have to multiply those to get how much I'm trying to make. Letter B, find the number of bottles needed to make 40, 120, and 224 square feet of carpet. So we're going to do this kind of like the last example. We'd be substituting the values in for the variable. So I'm going to get 3 separate answers here, but I would do 14 times 40 for the first. I would do 14 times 120 for the second, and 14 times 224 for the third. I'll leave it up to you to find how many bottles would be required to make each of those measurements. And that is it for the examples. Good luck on the exercises, and please let me know if you have any questions.